Hey kids, so we're gonna get into this unit 3 now. This is called Math Matters. We had to cut the thing short a little bit for matter, so there's a little bit of matter in here and a little bit of math. And then I'm gonna cut this one short to reduce the amount of math on one test, and then we'll have the next unit. Oh, this is unit 2 though, actually. Whoop. Unit 2. All right, so this is Math Matters Unit 2. We're starting with matter, and matter that you should have learned from the PhET is that solid has a definite shape and a definite volume, that liquids have a definite volume. There's definitely a space they'll contain, but their shape will be whatever the container is, and gas will take up the shape and volume of the container regardless. So you should have learned that playing around here with this thing, right? If you have a solid, you have a definite shape. If you have a liquid, the shape kind of gets a little uh, ambiguous, but the volume, it definitely holds a certain amount, and then the gas just fills the container no matter what the size of the container is. So the other thing, the main thing I was trying to get you to understand here is that the movement is related to the temperature, right? If we heat this up to a higher temperature, and you can see that temperature up here going up, right? 78, 79, and that's in Kelvin, the motion's increasing, right? There's more and more and more motion. And if we go the other way, the motion starts slowing down because temperature and motion are related. So as temperature goes down, the motion of the atoms or molecules, whatever you have in there, goes down. And as temperature goes up, the motion increases. That is very important. That's going to be a founding principle of everything we do this year. I'm going to talk to you about that a lot. The other thing that hopefully you notice is that solid liquid gas, no, not solid liquid gas, but neon to oxygen to argon, notice that the temperature is going up, right? Neon's 14, oxygen's 27, argon's 43. And that actually has to do with their mass, if you don't quite understand this yet. But neon weighs 20. Maybe some of you know that from previous classes. Oxygen weighs 16, but there's two of them, so that's 32. And argon weighs about 40. So neon is the lightest than oxygen than argon. And as you might anticipate, it takes more energy to move argon than it would, right? 78 Kelvin, and it's almost a liquid. Whereas if we have neon at 78 Kelvin, that's a gas because it's a lighter atom. So that should just make sense to you from a matter kind of standpoint. Like you understand that. So I'm getting up to 78 because I'm just, there we are. Right. So that's sort of a gas. So the bigger the object, the harder it is to push around. So it would take more energy, more heat to move bigger objects than smaller objects. Here's a little stone that the kid can throw, but here's a giant rock that this woman is pushing with a beard. I think that's a woman. Anyway. All right. So the big picture here is that temperature is measured in Celsius because this is a science course. We won't talk Fahrenheit ever, and it'll drive me nuts when you answer Fahrenheit on test questions. But so it's a red herring. Celsius is what we do. Sometimes we'll do stuff in Kelvin because Kelvin is what we call this absolute temperature. Absolute temperature means that it's related directly to the motion, and that when you're at 0 Kelvin, then all motion ceases. And you should have learned that here, right? If we have cooling, and as the temperature is going down to 4, 3, 2, so here we're down to 1 Kelvin. All right, it's not 0. There's still a little bit of motion there, and it's at 0 Kelvin that everything's going to stop moving. So that's why Kelvin is important. If I ever ask you to convert to Kelvin, the way to do that is using this temperature formula that Kelvin is equal to degrees Celsius plus 273. So it turns out absolute 0 that we just said, 0 Kelvin, that's equal to minus 273 degrees Celsius. And so they just made every Kelvin the same difference as Celsius so that it's exactly the same. So if you go up 100 degrees Celsius, you go up 100 Kelvin. So the difference between 100 degrees Celsius to 200 degrees Celsius is 100 degrees Celsius, and it's also 100 degrees Kelvin, because that would be 373 Kelvin to 473 Kelvin. So that's also 100 degrees Kelvin, if that makes sense. All right. I might ask you to know this, so you just add 273 to Celsius. So if it's 100 degrees Celsius, that would be 373 Kelvin. If it's minus 23, it would be 250 Kelvin. Moving on. Wow. moving on. Nope, sorry about that. Wow, kids, we're losing everything here. Here we go, moving on. All right, changes in state. So let's talk about these things. You should know these things. Solid to a liquid, you should have learned this at some point. That is melting. Now, why this is red and the other page is black, I don't know. If you turn a liquid back to a solid, that is freezing. So these are just definitions you should know. You should have learned these already at some point. Liquid going to a gas at any temperature, so not really heating it up, that's evaporation. If you're heating it up actively, then we call that liquid to gas at its boiling point. We call that boiling. So anyway, gas to a liquid, so turning steam into water, again, that's called condensation. And then here are the tricky ones, which we should, at some point, we'll have dry ice in the room. So dry ice is solid carbon dioxide, and it turns right to a gas. It skips the liquid phase. And that is called sublimation. All right. And then gas back to solid. So doing it in reverse, if they turn carbon dioxide into a solid dry ice and don't go through the liquid phase, they call that deposition, just like the legal term, deposition. All right. There you